All right, thank you. Hi everyone, my name is Jasmine Liu, and today I'll be presenting our project, ecoEDA, Recycling E-Waste During Electronics Design. As Michael named all of my co-authors, they're all here at UIST except KD Wu, so please reach out to us and connect with us and ask us about this project. So first, let me show you this electronic badge we made, modeled by Beza. This badge has various electronic components that you can see, like a screen, a microcontroller, vibromotor, and speaker. So to make this, typically people go through steps you might be familiar with during the electronics design process. First, creating a schematic of the design in an electronic design automation software, such as, or also known as EDAs. Then sourcing the components, assembling the prototype. And let's zoom in on this one section. Where are these parts being sourced from? Typically, these are sourced and bought anew via distributors like DigiKey or Mouser. But when components are bought anew with every single prototype we make, and every prototype could become e-waste after use, we are contributing to the millions of tons of e-waste that are generated annually. So what if we tried a more circular approach to this? What if the electronic parts we prototype with were sourced from e-waste? So in ecoEDA, we look at how we can support the more circular prototyping practice by building tools within design editors that actually support this process of recycling. Let's see how we can do this with e-waste. Take the Roomba, for example, a vacuuming robot. Like many devices, if this is broken or outdated, it will likely end up in the trash. In fact, we actually got this exact Roomba from the e-waste bin in the building next to our lab space. When you open up this Roomba, you'll find hundreds of reusable electronic components that could be incorporated into new electronics projects. And yes, you can reuse many of these, and we did build devices with the components on this board. Now, consider all the other kinds of devices that become e-waste, like single-use devices like this digital COVID test, your own prototypes, old obsolete devices, and even old drivers left over after upgrades, like after updating your Ender 3D printer. Drawing from these sources, we can generate a library of parts found in e-waste devices for use in our ecoEDA tool. So here, Beza is using KiCad to draft her circuit schematic. And as Beza creates the schematic, ecoEDA will give her real-time suggestions based on the component she adds. For example, one type of suggestion will be an exact match suggestion. An exact match suggestion informs Beza that there is the exact component she is using in her schematic available in the ecoEDA library. As you can see in the review window, the component is the same, but the suggested replacement is sourced from an old Nokia phone. After reviewing the info, Beza accepts this replacement, and ecoEDA then automatically substitutes the component into her schematic, as seen by the little leaf ecoEDA symbol. Now Beza can continue to work from this component sourced from a discarded Nokia phone and can continue on working on her design. In addition to exact match, we also made 4 other suggestion types to handle for distinct reuse cases, including drop-in replacements for components that are different but have the same footprint and pinout, exact match with different footprint for components that are the same type but have different packagings, and also rank suggestions, allowing users to filter through suggestions depending on their need. And finally, sub-circuit suggestions for when an exact component is not available but can be made by combining multiple different components in the library. Like in this case, this level shifter component can be made from a combination of transistors and resistors. Again, in all of these cases, the user can review these suggestions, comparing side by side on our interface, and then accept them. And now here the user can interact with the sub-circuit components as individual design elements. So after implementing this tool, we also did a user study exploring how people use the tool to reuse components. We ran a study with students from a class where they were able to actually tear down e-waste devices and inventory those components for use in ecoEDA. Using the libraries they generated from those torn down devices, they used ecoEDA to create new designs from those components. Across our participants, 66% of the components came recycled from e-waste. But more importantly, when we interviewed them about their process, participants discussed how they had to employ very different design workflows in consideration of reusing components than they were used to in a normal practice, how the experience demystified the insides of devices, and how they reflected on the wastefulness inherent to electronics prototyping and manufacturing. And finally, participants expressed how the tool made reusing electronics actually feel possible. In fact, 2 of our participants started doing reusing right away in their final class project after completing our study. So now, how can we use ecoEDA? And when I say we, I mean everyone in this room, because we are making ecoEDA open source, so you can all download our tool and use it on your own. We showed you one approach with Bayes' conference badge and also in our study, but as many of you are familiar, there are so many diverse approaches to prototyping with electronics. To open up the possibilities of what reuse could look like, we showed ecoEDA with toolkits like an Arduino, without manufacturing the PCB boards and instead using proto boards, and also through rapid prototyping with small-scale fabrication machines like a Volterra, making PCBs without having to wait for your components to be shipped to you, and instead sourcing them from stuff around you. In doing this work, we found some components are harder to reuse than others, and we go into depth about this in our paper. And really, I do want to stress that e-waste is a super thorny issue. E-waste is becoming a problem that we can't ignore, both in HCI and more broadly. And I don't think of ecoEDA as the only way to fight e-waste. In fact, there is growing HCI research posing creative approaches for more sustainable computing futures, such as all the papers in this session, which I'm super excited about. But we do think our approach is unique in exploring how e-waste can actually serve as an abundant resource for reuse and recycling in new electronic designs. What I'm excited about is how a tool like ecoEDA can allow us to act not just as a consumer or user of a device, but also as a recycler. And if you remember last year, I was here at UIST with a kind of similar proposition, exploring users as caretakers of their devices. I'm super interested in what can be enabled when we pursue research that invites us to take on new roles in our relationship to interactive devices, and excited to explore that with all of you. Thank you so much for listening. I'm happy to take any questions about our work, and we also have a demo later this evening, so please come by and bring all of your other questions to that.
Hi, I'm Joe from, is it working? Hi, I'm Jotaro from Sony R&D. Great system, thank you very much for your talk. And I was actually also impressed by the fact that you could just support ecoEDA Inc. Subcircuits, right?
Yes.
I was just curious, like, maybe I just saw that particular example. I've seen that one part became multiple parts of that, and then that's, if you think about the number of the parts, that's another future candidates for the e-waste, right? Have you ever thought about reducing the amount of the components rather than producing a bunch of them again? So.
Yeah, that's definitely true. And I think the idea behind subcircuits is that a lot of our IC chips, you can break them down into like simpler components and find new ways to like do the create the same functionality with like more fundamental components. But that's a great idea of how we can make like our EDAs more expressive, also in the tune of like finding ways to be more sustainable by reducing our component usage. So that's a great idea.
Yeah, I mean, what defines the simpler components? Because like one IC chip could be simpler, but I mean, producing another equivalent circuits with 8 components is probably, I don't know, maybe that's my kind of question. Yeah.
Oh, I see. That's true. I mean, I think that depends on the designer themselves. Are they willing to swap in to use a more numerous components in order to achieve a functionality, or do they really need to like have a tight design with just one chip? I think there's all these trade-offs that like what we're trying to explore is that we create an interface to allow you to evaluate these trade-offs and compare different approaches, but that ultimately, I think, it's up to the designer.
Thank you very much.
Yeah.
Okay, we have time for like one very short question, please. And can Madalena already set up the PC?
Yes.
Okay, fight for it.
So I think one quick question is that what do you see the opportunity or the challenge for reuse the e-waste in a larger scenario, like in mass manufacturing scenario? Yeah.
That is a great question. We definitely talk a lot about how when we design the tool, we design primarily for like engineers, people who are prototyping a lot, because we see that as like a very common use case, and also a use case that allows for like some failures and stuff. With reusing components, you're not buying from a supply chain, so you don't have the guarantee that you're going to have like, I don't know, 100 of the same component, right? You have to go out and seek those. So you have like a lot of constraints that are induced by trying to do this practice of reusing and scavenging components that you don't have. There's a lot more. Happy to talk about it more, but we should allow Madalena to talk too.
Thank you.
Thank you very much, Jasmine.